Okay, 5.62, we're going to continue working with inverses of a function. So let's start with reviewing what we did last class. So I'm going to find the inverse of f algebraically, and then I'm going to graph f of an f inverse. So we found them algebraically, the inverse algebraically in last class. If this is f of x equals 2x minus 4, we change the f of x to a y. Okay, and then to find the inverse, we change the y to an x and the x to a y. Okay, and then I'm going to go ahead and solve for y, and that's going to be solving for my new inverse function. Okay, instead of saying y equals, I'm going to go ahead and give it the name f inverse of x. Okay, now I want to do x over 2 plus 4 divided by 2 is 2. Okay, so this is the equation of the inverse. So now let's graph them both. We graphed them, but we didn't graph them at the same time as we were solving for them. So let me graph f first. The y-intercept of f is negative 4, and my slope is up 2 over 1. I'm doing an extra dots just to make it straight. Okay, this is a linear, so this is linear, so let me graph my line. Okay, and I'm going to go ahead and label that as f. Okay, now I want to graph my second function. Okay, so for f inverse, I have x over 2 plus 2. The y-intercept is 2. What's my slope? It's x over 2. So what is that? That's 1x over 2. My slope is up 1 over 2. Okay, let me go ahead and graph that. Okay, and then that one is f inverse. Okay, now it doesn't ask me to draw the line of symmetry, but I'm going to go ahead and draw it just so to remind you. My line of symmetry is y equals x. Y equals x is y-intercept 0. Slope is 1 over 1. So if I were to draw this dashed line down the middle, if I look at f and f inverse, it does look symmetric across that line. So that's how I verify my answer. Okay, let's try the next one too with lines. Just to refresh what we did yesterday. Okay, this is y equals negative 2/3 x plus 2. If you're comfortable skipping the first step where we change it to a y, you could just change the variables. I'm going to go ahead and show that step. Okay, this is the original function. To find the inverse, I change the y to an x and the x to a y, and then I need to solve for y. Okay, and if you're comfortable canceling the negative 2/3 all at once, you can. If you would like to do it piece by piece, you can do it piece by piece. I'm going to multiply by the denominator, which is the 3. So I'm going to do it in 2 steps. Okay, I'm going to multiply the whole right side by 3. And the reason we do that, remember, is to cancel the bottom 3 with the top 3. So I have 3x minus 6 equals negative 2y. Now I'll divide everything by negative 2. Okay, and then I'm going to go ahead and redo the notation. So this is the inverse of f, so f inverse of x. Okay, 3x divided by 2 is negative 3 over 2x. Negative 6 divided by negative 2 is positive 3. Okay, I'm going to go ahead and graph f and f inverse. And I just want to look and see if it looks like they are in fact inverses of each other. So f of x is negative 2/3 x plus 2. Y-intercept is positive 2. My slope is down 2 over 3. Okay, it's linear, so let me make it a line. Okay, and I'm going to label that as f, just so I keep track of which one's which. Okay, what's my inverse? F inverse of x is negative 3/2 x plus 3, so the y-intercept is 3. I'm going to go down 3 over 2. Okay, and even though it looks funny, I'm going to go ahead and graph it, and then when I look at it at the end, I'll check the symmetry line. F inverse. Okay, now sometimes when I look at it, I think that doesn't look right. And then when I do the symmetry line, it helps me realize it's okay. So the line of symmetry is y equals x. So y-intercept is 0, up 1 over 1. Okay, dashed line. Okay, and then once I draw that line, it does look like this is reflecting over this. It does look like I'm a little bit off though. Let me see, double check my lines. Okay, y equals negative 2/3 x plus 2, up 2, down 2 over 3. What about this one? Up 3, down 3. Oh, I did get off. Okay, so the line of symmetry is helping me realize that I graphed this one a little bit off. Okay, so let me fix that. Okay, so y-intercept was 3, and then I went down 3 over 2, so it should actually be right around here. See if that looks better. Okay, and let me fix my f. Does that look better? Oh, that does look better. So this is my y equals x, and now it does look symmetric across that line. Okay, now we're going to keep finding the inverse algebraically, but now we're going to do some functions that are a little bit more interesting than lines. Okay, so I'm going to do the same process. So f of x equals x squared plus 10. They're giving me this weird domain, which is x is greater or equal to 0. Later when we graph it, we'll see why that is true. But for now, we're just going to say that's a fun fact for us to know. Okay, so this is y equals x squared plus 10. Okay, to find the inverse, I change the y to an x and the x to a y. Okay, now I need to solve for y. So I'm going to minus the 10 over. X minus 10 equals y squared. Now how do I cancel this squared? I square root it. Okay, I get y equals. Okay, now here's where this weird domain situation comes into play. Okay, normally when I solve a quadratic and I square root something, I get plus or minus the square root of x minus 10. They're telling me that on f, I only care about the x's that are greater than 0 or equal to 0, which means for the inverse, I only care about the y's that are greater or equal to 0, which means I only want to do the positive square root of x minus 10. And I don't care about the negatives because of this weird restriction here. When I graph it, it'll make more sense, but for now we're just doing the algebra. Okay, so I solved it. What was I trying to find? The inverse. So f inverse of x is the positive square root of x minus 10. Okay, let's go ahead and try the next one. G of x equals 2x to the third minus 5. Okay, so this is the same as y equals 2x to the third minus 5. To find the inverse, I change the y to an x and the x to a y, and I solve for y. Okay, what do I need to divide by 2. Okay, now I can leave this as a big fraction. I can make them individuals. It's kind of up to me. But to cancel the third power, I need to do a third root. Okay, now when I do a third root, do I need a plus minus? No, so I'm not worried about the sign. I'm going to leave it exactly like this. Okay, and then what was I actually trying to find? I was trying to find g inverse. So let me just rename this function as g inverse of x is the third root of x over 2 plus 5 over 2. And you could have a different but equivalent expression. Like I could have left it as a big fraction on this step, and it would be the same result. Let's try a couple more. If you feel confident, go ahead and pause the video and then fast forward to the answers. Okay, this is the same as y equals the square root of x minus 2. To find the inverse, we're going to transpose y goes to x goes to y. Okay, then I'm going to solve for y. Since the y minus 2 is trapped in that square root sign, to cancel a square root, I square. Okay, let's add the 2 over. Okay, and then this is the inverse of h. So h inverse of f is x squared plus 2. There is a domain restriction, but we're not going to worry about that quite yet. Let's do one more algebraically, and then we'll look at the graph. Okay, g of x is the same as y equals. Okay, to find the inverse, I change the y to x and the x to y. Okay, I know I want to cancel the cube root, but this 2 needs to go first. So let me divide the 2 first. Actually, it doesn't need to go first, but I would have to cube it, so I'd rather move it first. Okay, now I have this third root by itself. Let's third power both sides. Okay, what is it? X to the third. 2 to the third is 8. Okay, which just minus the 4 over. Okay, and then let me rewrite that as the inverse of j. So j inverse of x is x cubed over 8 minus 4. Okay, last example, let's put it together. Let's solve it, and then let's also graph it, and then we can also see why the domain restriction is in place. So for example, 5a, it says f of x equals x squared minus 2 only for x is greater or equal to 0. Okay, we'll look and see why that restriction matters in a second. So let me rewrite this as y equals x squared minus 2. To find the inverse, I change this. Okay, y squared square root. Okay, when I square root y, something squared, I normally get plus or minus. Because they're saying x is greater or equal to 0, then I actually, for the inverse, I want the y's to be greater or equal to 0. So it's going to be the positive square root of x plus 2. So f inverse is the square root of x plus 2. Okay, let's go ahead and graph this now. Okay, I think I'm going to actually graph the inverse first. Okay, it's a square root function, and it's moved left 2. So left 2. Square root of 1 is 1. The square root of 4 is 2. So from here, 1, 2, 3, 4, up 2. And then let me sketch that, and I'm going to label it. That was f inverse. Okay, now I want to graph x squared minus 2. Don't copy it yet because I'm going to erase part of it. So it's a parabola and it's moved down 2. So normally we would go down 2. I would do my little 1, 1. I would do my 2, 4, and I would sketch it in, which I'm going to do, but then I'm going to fix it. Okay, let me draw this. Okay, it would look like this. Okay, now one thing, I can already tell that if I drew the axis of symmetry, the y equals x line, it's not going to look right. There's too much going on. Okay, so now I'm going to look at the restriction. They only want me to graph x is greater or equal to 0. So x is 0 is right here. X is 1 is here. So this is good. X is 2 is over here. If I go on this side, x is negative 1. These are all the x's are negative. So I actually want to erase all the side where x's are negative. So I'm going to erase this. Okay, so this is the parabola, but I'm only including the part where x is greater or equal to 0. Okay, now that I see it, it looks like it is the inverse of f inverse. Okay, I'll draw the y equals x line to check y equals x. But when I draw the line, now it looks like they are inverses of each other. If I don't do the domain restriction, they don't look like they're inverses of each other. They're actually not functions. They would fail the vertical line test. Okay, so if there's a domain restriction, it's in order to make sure that the functions are functions and that they do turn out to be inverses of each other. Okay, let's do one more with a weird domain. Okay, this is f of x equals the square root of x minus 3. I think I'm going to actually graph it. Okay, this is a square root function. It's moved to the right 3. 1, 1, 2, oh, I'm going to go off the graph. So somewhere over here. Okay, and this is the graph of f. Let's find the inverse. Okay, to cancel the square root, I'm going to square it. Oh shoot, I didn't transpose my letters yet. Okay, pause. Find the inverse. I need to change the y to an x and the x to a y. So x equals the square root of y minus 3. Now let's square both sides. Okay, and then I'm going to add the 3 over. Okay, so f inverse of x is going to be x squared plus 3. Okay, now if I graph x squared plus 3, that's a parabola. It goes up 3. Okay, and then this is going to look like this. And I know that's not right because this only looks like half a parabola. So there must be some kind of restriction. Okay, let's think about how to make this look right. Okay, so let's look at the square root function. For the square root function, we're only including the y values that are greater or equal to 0. which means for the inverse, if the y is greater or equal to 0 on the original function, then the x is greater or equal to 0 on the inverse function. So let me graph x squared plus 3, which will look something like this. But I only want to include the x values that are greater or equal to 0, which means I need to erase all the x's that are negative. Okay, now let me draw this half a parabola in, and I'm going to make sure it looks right. Okay, so that's what I got for f inverse with the domain restriction. And then if I draw the y equals x line, they do look like they're symmetric across this line, so this should be correct. If I forget about the domain restriction when I graph it, they will not look like inverses of each other.